Bismillahirrahmanirrahim. This is Unit 10 Simple Harmonic Motion, Exercise MCQs, Physics 10, National Book Foundation. Question 1. A mass spring system has mass m attached to spring. What will be effect on its time period if its mass is increased 4 times? Since it's a mass spring system, on a mass spring system, if mass increases, it reduces the speed. Imagine if there is a spring attached with a mass. If we increase the mass, what will it do? The same spring will move slowly with the heavier mass. So slow speed means more time. So that means that out of these options, the time should be more, it should not be half, and it should not remain same. So it can become double or it can become 4 times. All right. Now we will see what happens. The time period can be calculated as 2 pi m over k. When mass increases to 4 times means it becomes 4m. So substitute 4m and the time dash will be equal to 2 pi 4m over k. Now, square root 4 is equal to 2. So put 2 here. This 2, I have taken out the square root 4 to 2 and it is 2 pi m over k. This portion, 2 pi m over k, is the same as this time period. So I can write it as t dash is equal to 2t. So that means the new time period becomes double the original. So the correct answer is the time period becomes double. Question 2. A spring is stretched by 5 cm by a 20 Newton force. What is the spring constant? The given options are 100 Newton, 400 Newton, 40 Newton per meter and 4 Newton per meter. F is equal to minus kx. The force F by the spring and the displacement x are always in opposite direction in a spring mass system. The negative sign represents the opposing directions, this negative sign. This is always a restoring force. It always goes toward the center. That is also the meaning of the sign. However, when we say k is equal to minus F over x. Now substitute F is equal to minus 20 Newton, x is equal to 5 cm. That means 5 over 100 is equal to 0.05 meter. Now, just note, I have taken this force as negative 20 because if displacement is 5 centimeter in one direction, the force has to be in opposite direction, so it will be taken as negative 20 Newton. So, calculating k using this formula, k is equal to minus 20 over 0.05, this minus cancel with this, and cancelling these two decimals, put 2 zeros in the numerator. Now further calculating this gives us k is equal to 400 Newton per meter. The correct option is 400 Newton per meter. Question 3. If amplitude of simple pendulum is doubled, what happens to its time period? Time period t is equal to 2 pi L over g for simple pendulum. Time period primarily varies with length L or if the value of g changes at some spontaneous location. So change in amplitude does not affect the time period. Hence, the time period remains same. Note that increasing the amplitude increases the speed of the pendulum and keeps the time period same. So the correct option here is time period remains same, the option D. Question 4. time period of simple pendulum will be smallest at Mari, moon, poles or equator. Now time period is 2 pi L over G. Time period depends on length L of the pendulum and the value of G on the place where the pendulum is operating. So if length is kept same and only G is the variable, then time period will be smallest where G is maximum, because G is inverse in the inverse proportion. It is the square root of G. So when G is maximum, the time period should be smallest. Now we have to see where is the G maximum. Moon is 1/6 of the G of Earth. So moon cannot have a smallest time period. It should be the largest time period as such. Mari is a mountainous place, so it is away from the equator. It should have more the radius, so time period is less. So we know that the formula for the value of G is equal to capital G me over r square, where G is the constant of gravitation, me is the mass of the earth, and r is the radius of the earth. This formula you studied in class 9. Now we know that G and me are constants. For earth, G and me are constant. Only variable is the radius r. Since shape of the earth is elliptical and it has the smallest radius on poles, therefore, now see, this shape of the earth is elliptical. If this is the center, this radius, this is called equatorial radius, and this is called the polar radius. Since earth has a bulge out on equator due to its rotation, the radius on equator is more than radius on poles. So since the shape of the earth is elliptical, it has smallest radius on pole, therefore the value of G on poles is maximum. So time period for the simple pendulum will be smallest on poles, North Pole or South Pole. So the correct answer is C, poles. Question 5. If a body performing simple harmonic motion completes one vibration in 2 seconds, its frequency of vibrations is. There are 4 options: 2 Hz, 1 Hz, 0.5 Hz and 10 Hz. Now completing one vibration in 2 seconds means time period T is equal to 2 seconds. Frequency is the reciprocal of T. Hence, it can be written as F is equal to 1 over T. Which is, since time period is 2 seconds, it is 1 over 2 is equal to 0.5 Hz. Frequency is 0.5 Hz. C is the correct option. Question 6. 360 waves are passing through a point in a river in 1 hour. Time period of the waves is. Now, time period is the time taken by a wave to pass through a point. Since it is given that the total time is 1 hour, converting it into second makes it 3600 seconds. Time that 360 waves take to pass a point is given as 1 hour, which we now know that it is 3600 seconds, so write it as 3600 seconds. So time that, using the unitary formula, the unitary method, we know that 360 waves take time 3600 seconds, so 1 waves takes to pass the point 3600 divided by 360 seconds. So calculating this, 3600 divided by 360 gives us the time period for one wave, that is equal to 10 seconds. So correct option is C, 10 seconds. Question 7. Time period of electrical vibrator of ripple tank is 0.5 seconds. Water waves in ripple tank has speed of 10 meter per second and amplitude of 5 centimeter. The frequency of waves. Note that the time period of electrical vibrator is same as the time period of the waves produced by this vibrator. So time period of the waves is also 0.5 second as it is for the vibrator. Now recall that the frequency f is the reciprocal of the time period t, written as f is equal to 1 over t. Since time period for the vibrator is 0.5 and same as for the waves, so substitute t is equal to 0.5 seconds, f is equal to 1 over 0.5, and this result in 2 hertz. So correct option is option D, 2 hertz. Question 8. Which one of the following is a longitudinal wave? Longitudinal waves are the waves whose disturbance of particles is parallel to the travel of the waves. That means the direction in which the wave is moving, the particles of the medium also move in the same direction. X-rays, light and the string waves are the transverse waves since their particle disturbance is perpendicular to their travel. Moreover, X-rays and light are both electromagnetic waves and they are transverse waves. Only sound waves are longitudinal waves which have the same direction for the particles as well as for the direction of the wave. So the correct option here is sound. Question 9. When water waves enter from deep water to shallow water, the frequency of water wave increases, time period of water wave decreases, speed of water wave decreases, wavelength of water waves increases. When water waves enter from deep to shallow, water interacts with the bottom surface. Due to this interaction with the bottom surface, the wavelength of the water waves decreases in shallow region. The frequency of the waves always remains same as originated from the source. Since V is equal to F lambda, a decreased wavelength means decreased speed. So the speed of the water wave decreases. Option C is the correct option. Question 10, the last question. Listening to radio transmission in deep valleys of mountain areas is due to, these are the 4 options given: reflection of waves, refraction of waves, interference of waves, and diffraction of waves. Radio waves travel through open space. Though it bends over the sharp edges and are able to reach the regions behind the obstacles as well. This is because of bending through the sharp edges. Mountains are considered as secondary source for the radio waves. Mountains are considered as secondary source for the radio waves because the radio waves bend over the sharp edges over the mountains and go through all the directions, which covers the deep valleys too. That means after bending from the sharp edges over the mountains, it bends down as well and goes to the deep valleys. Phenomena of bending the waves from the sharp edges corner is called diffraction. So radio waves reach the deep valleys of the mountains due to diffraction of waves. The correct option here is diffraction of waves, option D. If you haven't subscribed the channel yet, please subscribe it so that you can benefit from my future videos timely and you can be able to prepare for your exams and learn from the videos. If you have any specific problem in any chapter or any question, please write it in the comment. It will reach me and I will be able to answer your question on any video or in any future forum. Thank you.